Hey everyone, this is Udaditya from TechSpark with another session covering data engineering question and answer. And today's topic would be the benefits of Spark SQL. We're going to discuss how the API, the data frame API of the Spark SQL, or even the SQL API for that matter, is helpful for us, and what happens underneath that it's much more efficient, much faster than the RDD API. So before going to that, a bit about myself. I have been working in data engine domain for almost 9 years with various projects and involved in creating data pipelines for several clients. I also train candidates in this field to help them build an intermediary profile with a comprehensive course covering all the necessary topics of data engineering. So in one of the previous sessions, we did discuss about the differences between the two most talked about APIs in Spark, that is the RDT and the data frame. There is another set of API, which is dataset, which is kind of like hybrid, but it is not available in Python or as in PySpark. But if you try to highlight the differences between RDD and data frame API, obviously the way data structures itself when we try to return the data set or the result set to the console, in which case we saw the for the RDD, it comes as a tuple, it's like a normal data structure in Python or Scala. But if I want to analyze the data, if I want to get each and every attribute with a predefined schema, in that case data frame API does help a lot, because data frame API structures itself in a much better way, in a much more visually helpful way. So we can analyze each and every column, we can have a predefined schema, and the data types are also there. So it's much easier for us. But is it the only reason why you use data frame API? There is one more reason, and that reason is Catalyst Optimizer. So before coming into Catalyst Optimizer, there is one more thing I want to remind you, that when I was covering the data frame API, in one of those points, I did mention that at the end the data frame gets broken down to RDD, right? And I did say that I will explain how this happens later. So this is where I'm going to showcase how this thing happened, and there are different steps by which the data frame does get broken down to RDD. And it's not only the data frame API, as I showed you, right? In the Spark SQL, you can also write SQL queries such as select star from table name, and that can also converted into RDDs for faster processing. So in the RDD API, what was happening, that you were writing the code in RDD, and then it was totally up to you to make the code efficient or make the whole structure optimized. All right. But now with the Catalyst Optimizer, what's happening is that in the data frame API, when you're writing the code, in that case, you just have to take care of the functional things. I mean, if you're selecting some columns, if you're filtering upon some columns, if you're doing group by, join, and whatnot operations, you need to think about those. The underlying Catalyst Optimizer will automatically turn your query into a much more efficient and optimized one, and then the whole chunk, I mean, each and everything will be broken down to RDD before processing. Okay, so that's the beauty of it, is that when you're writing the code, you don't have to keep in mind how should I query, how should I make it more optimized, how should I make it efficient, because now Spark will handle these things by itself. All you have to do is just write the code by yourself. Okay, so if you look at the diagram over here, so there are certain ways, there are certain steps through which this SQL query or the Terraform API, whatever I may want to use, is getting converted into RDDs. So there are certain steps by which it's happening. So if I try to break it down, what's happening? So at first, that you write the data frame code or the SQL query, and it creates an unresolved logical plan. Now, what is unresolved logical plan? Okay, so if you see over here, what's written? Spark SQL begins with a relation to be computed either from the abstract syntax tree returned by an SQL parser or from a data frame object constructed using the API. Okay, so whether you choose the SQL one or the data frame API or the data frame API, it will return an abstract syntax tree. Okay, so this AST is basically an unresolved logical plan. So this will give a layout of the code that you have written, all the steps that you have put, but it is not an efficient one. It is not, so to speak, can be run in any cluster, so that it can make sure that it will run in an optimized and efficient way. Right? For example, if the SQL query select call from sales, the type of call or even whether it's a valid column name is not known until we look up the table cells. An attribute is called unresolved if you do not know its type or have not matched it to an input table. Spark does the analysis by referring to the Spark catalog and validate with the metadata. So at first, if you're writing an SQL query or even if you're using the data frame API, you put some column names, right? Whether you want to select or you want to filter out. So those column names that you write in the compile time, Spark doesn't catch whether those are the correct column names, right? I mean, that's one of the caveats in data frame API. So to help with that, the unresolved logical plan will simply connect with the catalog. And Spark catalog is where all the metadata information of the table that you're using or referring to in your Spark code is stored. Metadata information such as the table schema, each and every column name. So to validate all the column names that you're using in your SQL query or the data frame API, Spark will take the help of the Spark catalog. So once this is validated, then only this unresolved logical plan will turn into a logical plan. Okay, so that's the first step. First step is simply connecting with the Spark catalog, and then it will check whether all the schema and everything that you're putting in your code is correct or not. Okay, so now we have known how to convert the unresolved logical plan to the logical plan. Now the next step is the logical plan optimizer. So once your logical plan is built, then that's just the first of it. Secondly, it starts analyzing the user's query and generating an initial logical plan. The optimizer applies a series of rules to the logical plan to imply or reorganize operations such as predicate pushdown or projection pruning. Now, what are these two terms, predicate pushdown and projection pruning? So before that, I want to say, suppose you have written a 10-liner Spark code, right? You're doing some join operations, you're doing some filter operations, you're doing some group by, and at the end, you're probably selecting a subset of columns from the table. So the way Spark works is that it will try to unload the data as much as possible right at the beginning. Okay, so when you're doing all the operations, it is trying to make sure that you don't do those operations at a larger data set, but only the required subset or only the required set which you need at the end. Okay, so there are two terms, predicate pushdown. So one, so this thing means if you're putting any filter in your code and you're putting that filter suppose in the middle or even at the end, and the filter column that you've put that is already available in the existing table, in that case that will happen at the very beginning. Okay, now let me put it in layman terms. Suppose you have a table that has say 1 billion rows. Okay, now what you're doing, you're putting a filter halfway at the code that will simply chunk it to almost 10,000 rows. So instead of 1 billion rows, you require only 10,000 rows. But even before using the filter, you're doing some join and group by operations. So that's not an efficient code, right? So, but it's not required for you to write the efficient code. The Spark will handle it for you. So what Spark will do? Spark will simply put the filter even before the join or group by. So initially, the 1 billion row will be reduced down to only 10,000 rows, and then your join or group by or all the operations, all the other processing or the transformations that you have put in your code will be applied on them. Okay, so that is the predicate push down. Second one is the project pruning. Project pruning means only the required set of columns will be taken at the time of processing. So again, suppose you're doing a hell lot of join, group by, and transformations, be it narrow or wide transformations. You're putting all of this into your code, and at the end, out of say 100 columns, you're picking only 10 columns. So basically, you need to put all those transformations only for those 10 columns, right? Rest of the 90 columns are not being used at all. So why you are just wasting your time? So in this case also, what Spark will do, even if you have written the select column transformation at the end, it will only fetch the 10 columns that you require at the very beginning, and then it will try to do the join or the any sort of aggregation or windowing, whatever transformation you have written in your code. Then so this is how basically Spark is going to reduce the load of the data as much as possible, so it works much efficient and a much more optimized way. So this is how the logical plan optimization goes on. The second part is the physical plan. I'm sorry, it's not the second part, it's actually the third part. Because the first part was the unresolved logical plan. It was with the help of Spark Catalog, it was getting turned into the logical plan. Now the second part was this logical plan optimization, where with these simplifying or reorganizing rules such as the predicate pushdown and the projection, the logical plan optimized is getting into physical plan. Now, after the logical plan is optimized, the catalyst optimizer generates multiple physical plans which represent how the query can be executed on the cluster. Okay, so now Spark has laid out the total roadmap. I mean, it has first checked with the Spark catalog for the metadata validation. Then, after doing all such operations such as filtering out the data or selecting only the required amount of columns, it has reduced the load. Now there is the ultimate plan that is there, and it's known as the physical plan. Okay, so the catalyst optimizer generates multiple physical plans which represent how the query can be executed on the cluster. So that is the final plan. It evaluates these physical plans based on their cost, that is the IO, CPU usage, and memory, and selects the most efficient one. So these physical plans will contain different set of query tree or query structure. So I mean, if I say that I want to do these things, so there are 10 different ways that I can do these things, right? So out of the 10 different ways, I have to pick the one which takes a lot. Sorry, it takes a very low cost path. And over here, the cost means the IO throughput, CPU usage, and memory. Because at the end of the day, your Spark job or Spark application will utilize the cluster resources that the container or the node manager has been provided with. Okay, so keeping that in mind, just to make sure that it's not taking a hell lot of CPU cores or even it's hobbling out a lot of RAM. So it's gonna lay out or it's gonna pick the best physical plan possible, and then the whole thing will get turned into RDD. Okay, so after all these things, the RDDs are getting created and then they are getting processed. So this is the whole flow of the catalyst optimizer. These are the steps through which the data frame API with the couple of optimizer or with the best efficient plan, it converts them to RDD and then it goes into operate. So you see, you just writing a simple Spark code, and with the help of this catalyst optimizer, it can automatically generate the best efficient plan for you. You don't need to do it on your own. When you're writing the code, you don't have to keep this in your mind at all. So this is the beauty of it, the catalyst optimizer. And if I talk about the benefits, obviously it has a lot of benefits. One is the performance gain. Automatically optimizes queries to execute faster and use fewer resources. So the optimizing the queries is where the predicate pushdown and the projection tuning coming in to reduce the load and to execute faster and use fewer resources. So the using fewer resources is part of the physical plan generation. The physical plan, only the one which is taking less amount of IO or CPU usage, that will be used. Second is ease of use. Users can write high level queries without needing to worry about low level optimization details. So this is the thing that I'm emphasizing more and more. In case of Spark RDD, you have to uh, sort of think of making your code much more efficient, making it much more optimized so it doesn't take a lot of time. But when you use the data frame API, all of this hassle simply just gets withered. Spark Catalyst Optimizer will take these things on its own automatically, and you just have to write the high level query. Okay. Third one is the scalability, ensures efficient execution of queries across large data sets in distributed environments. And the last one is the integration with various data sources, works seamlessly with structured, semi-structured, and unstructured data sources. So whatever be the data sources, either from Hadoop cluster or a cloud storage, and even if my data is not structured or semi-structured, all those cases will be handled by the Catalyst Optimizer. So this is the reason why the data frame API is much more popular, and in fact everywhere in all the projects the data frame API is used. Catalyst Optimizer does the job very easy for us, and it takes a very less amount of time to run our code if I compare the same with the RDDs. So that's all from this session, folks. Reach out to TechSpark to know more. We cover all the necessary tools in our data engineering course, such as Spark, Hadoop, Hive, AWS, with hands-on coding and real-world project. We also will help you set up Hadoop clusters and Hive console in your local system, and also Apache Spark. We will also show you how to get started with the Databricks platform, the community edition, and obviously at the end we will take some mock interviews to make your profile job ready, and we will assist you in getting the job. So that's our delivery promise. Just reach out to us for any query. For the moment, I'm signing off for this session. Bye bye.
Contact us for the free job assistance. We will help you to get the IT job. Please like, subscribe, and share the channel for more regular updates from TechSpoke.